This is very nice question about superposition of waves and stationary waves. You need to use principle of superposition. So let me write down here principle of superposition. You have to use this principle. Principle of superposition simply tells us that resultant displacement, you can say the displacement of resultant wave. So in this case, I'm just saying the resultant displacement. This is vector sum of individual displacements. Vector sum of individual displacements. So this is what is principle of superposition. Vector sum of individual displacement of waves. Individual displacements. Now for this question, the answer, let me show you the answer, then I will explain to you. Answer for this question is A. So why this is the answer? So let me explain to you why this one is the answer. If you look at point J now, in this case, first thing you need to understand, this wave is stationary wave. It is given to you. This one is stationary wave. So let me use this different color so to make it more clear to you. So this wave is a stationary wave, means the red one, this wave is the stationary wave, mean this is the resultant wave. Stationary wave simply means this is the resultant wave of two individual progressive waves, or you can say traveling waves. The sum of those two is this stationary wave. This is the sum of two waves. Now if you look at this point now, at this point, progressive wave, its displacement is equal to 0. But in this case, you can see stationary wave, it has displacement that is equal to -5. So the -5 is equal to 0 plus here also has to be the displacement of another wave, and that one you will simply say this one has to be -5. So that's the reason we got here this is -5. So this is at point J. Now if you go to point K, at this point you can see at this point in this stationary wave, its displacement is 5 plus 5, so we can say this one is plus 5, and this progressive wave displacement is also plus 5. How about the displacement of other wave? That one simply you will say it has to be 0. So that's the reason this one is 0, and this is at K. Now if we go to point L, at this point, this is point L, you can see the stationary wave, its displacement is equal to 0. But if you look at the displacement of progressive wave, this is plus 10. So this one is plus 10. How about displacement of second progressive wave? I hope you will say that one has to be minus 10. So the sum of these two, this one has to be equal to 0. So that's the reason this one is minus 10 and this is at L. I hope this one is clear to you. So this is how stationary wave is formed. Stationary wave is formed when two progressive waves, they are moving in opposite directions. Then stationary wave is formed. So that's the reason answer for this question has to be A. I hope this one is clear to you. Okay, if this one is clear, let's move on to the second question now. First of all, try by yourself. Answer for this question has to be C. So let me explain to you why answer is C. First thing you need to understand, it is given to you the first loud sound is heard when the air column in the tube has length x, means at this point. So the better way we can simply say here we heard the first loud sound. So the first loud sound we heard at this point. First loud sound. So we hear first loud sound, so simply you can say first loud, or you can say this one is the first maximum. So another way to understand this one is this is the first maxima. So we got first loud sound at this point. So in this case, you will say the waveform here, the stationary waveform, this one has to be this one. So this one has to be the stationary waveform at this point. Now, the second loud sound is next time, means the next loud sound is heard when the air column in the tube has length y. It means this one is y. So we can also form the next harmonic. So this one is the next harmonic. So simply you can draw this one is the next harmonic. We can draw a little bit in a better way so it looks nicer. So simply we can draw this one. So this is, you can draw like this. Okay, so this is next harmonic. Now in this case you need to understand, if you look at this part, this is lambda by 2. This is one node you have here and we have one node here. Distance between two nodes, this is equal to lambda by 2. So we can say distance between two consecutive nodes, distance between two consecutive nodes, that distance is equal to between two consecutive nodes. Any two consecutive nodes, distance is equal to lambda by 2. So it means this distance is equal to lambda by 2. So in this case, I can simply say that y minus x, that is equal to lambda by 2. And question is asking you to calculate lambda. So the lambda simply is equal to y minus x. 2 times y minus x. So that's the reason this one is the answer. Okay, so this is how you can figure out answer. Very common question. You will see this one in many past papers. So at this point we have second loud sound. So we can also write down here second loud sound. You can say the second maximum at this point. When the height is this one, y, we will hear the second maximum or second loud sound. I hope this one is clear to you how to approach this problem. Let's move on to next one. Look at this question and try to answer. It's very nice question. You need to understand the concept, not only the answer. So first of all, please try by yourself. Very nice question about stationary waves, about harmonics. You need to understand what is harmonic, overtone, and what is maximum. These difference you need to understand. So for this questions, you need to understand harmonic, you need to understand overtone, we will discuss these things, and you need to understand maximum. So these three different terms you need to understand. I will try to explain you these three different terms with the help of this question. So first of all, try by yourself. Okay, after 1 minute, I will show you the answer and then I will explain you in detail. I will teach you this one using different methods. One method I will teach you only for exam, and one method I will teach you to understand this kind of problems. Okay, so let me show you the answer. If you have got this answer, wonderful. If not, so now you can listen my explanation. First of all, you need to understand, in this case, it is given to you the stationary wave which gives the first maximum has a node at one end and antinode at the open end. Node at the closed end and antinode at the open end. So it simply means that we are talking about one end closed pipe. So this is the first information you can get from here. One end closed pipe, you can say one end open pipe. So I will simply say one end closed pipe. So this is first thing we can get from here. Now the second thing you need to understand is that if it is one end closed pipe, only odd harmonics are produced. Only odd harmonics. So you need to understand, if it is one end closed pipe, only odd harmonics are produced. I simply say, I'm saying only odd harmonics. Now we need to understand the difference between harmonics and maximum. Question is asking us to calculate frequency of the loudspeaker when the fourth maximum is heard. Fourth maximum. So let's try to understand the difference between them. Fourth maximum. So fourth maximum, let's try to understand what is difference between maximum and what is difference between harmonic. As I mentioned here, only odd harmonics. It means that first harmonic frequency will be F1. Second, in this case, the harmonic frequency will be F3. And the third one, frequency will be F5. And the fourth one, frequency will be F7. Only odd harmonics. Now we need to understand F7. This harmonic means the seventh harmonic. For this one, F7 has to be equal to 7 times of F1. So this is what meant by F7. F7 means this is seventh harmonic. So its frequency 7 times of fundamental frequency or first harmonic. So simply you can find answer from here. If you look at this one, you can find the answer. Now let's try to understand difference between maximum, overtone and harmonic. You can look at this figure. In this figure, it is very clear to you. First of all, you can see what is first harmonic. When 1/4 of the wave is inside the pipe, we call this is first harmonic. When we have 3/4 of the wave inside the pipe, we call that one is third harmonic. When we have 5/4 of the wave inside pipe, we call that is fifth harmonic. 5/4 means that if you look at this one, this is 1/4, lambda by 4. This is second quarter, this is third quarter, this is fourth, and this one is the fifth. So when we have 5 lambda by 4 inside the pipe, we call that is fifth harmonic. And we have when 7 lambda by 4 inside the pipe, you can say 7 by 4 waves inside the pipe, we call that is seventh harmonic. and so on. When we have 9 by 4 lambdas inside pipe, we call that is ninth harmonic. From here simply you can see we have only odd harmonic: first, third, fifth, seventh and ninth. Now let's try to understand maximum. This one is called first maximum. So let me write down here. This one we call is first maximum. So the first one is first maximum, means the first loud sound, and the second one, this is second maximum. So this one we call is second maximum, and next one we call this is third maximum. This is third maximum, and this one is fourth maximum. So this one is fourth maximum, and this one is fifth maximum. So you need to understand the difference between maximum and harmonics. In the question, it is given to you, this is fourth maximum. Fourth maximum simply means that this is the seventh harmonic for one enclosed pipe. So this is seventh harmonic. So if it is seventh harmonic, it means F7 is 7 times of F1, and you can figure out answer. Now if you look at two ends open pipe, two ends open, you can compare these two ends open pipe, two ends. So you can see here we have first harmonic, and we have second harmonic, we have third harmonic, and we have fourth harmonic, and we have fifth harmonic. You see in this case we have odd and even harmonics. We can say odd and even harmonics. So we have odd and even harmonics in case of two ends open pipe, two ends open. So this point you need to understand. Now you can also compare maximum. So we have first maximum. So this is the first maximum. This one is second maximum, and this one is third maximum, and this one is fourth maximum, and this one is fifth maximum. So we have discussed until now harmonic and maximum. Now let's try to understand about overtones. You see, this first harmonic is called fundamental, and rest of the tones, harmonics, we call them overtones. So the next one is the first overtone. This is the second overtone, third overtone, and fourth overtone. Okay, overtones start from the second harmonic, meaning the first overtone is second harmonic, or second maximum. So the better way I will say is first overtone is second maximum. First overtone is second maximum. So this is better way to remember this one. First harmonics is second maximum. Second maximum. So in this case you see second maximum here for one end closed pipe, second maximum for two ends open pipe. First overtone start from second maximum. So these things you need to understand about stationary waves for one end closed pipe and for two ends open pipe. So if you have understanding of these points, you can answer questions about one end closed pipe and two ends open pipe. I hope this one is clear to you. Let's go to next one. So this slide is very important. You can take notes of this one. You can take screenshot for your future reference, because this one is very important. I have explained a lot of points, because most of the students are confused with, they don't understand what is difference between maximum, what is difference between harmonic and harmonic number, and also overtone. They don't understand these things. So if you have understanding of these things, these questions are quite straightforward. Let's move on to next one. Look at this question and try to answer first of all by yourself. Let me give you the hint. It is given to you powder formed four heaps. It means these are the nodes actually, because the powder at those points will stay at rest. So these are the nodes. So due to waves, it will be compressed, mean powder will be at nodes. So I can label this one. We have node here, we have node at this point, we have node here, so we can label them. So the systematic approach is this one, and here we will have also node, because you see the heap is here, and here we will have antinode. Now in this case we have node here, and so I can label this point. Here will be the node, and so here we will have node, here we will have node. So you can label like this, and then you can draw the stationary wave, and then you can figure out. So here we have antinode here, so I can also draw, in this case here will be antinode here, so here we will have antinodes at these points. So we can also label these points, so we can draw a proper stationary wave inside this pipe here. Now first of all we have antinode here, so you can simply draw like this. Okay, so we have antinode, so we can simply draw wave like this. So this one is over one wave. So this is, you can draw, you can connect these points. So somewhere like this, you can draw. So this is, we can draw stationary wave. Now you can also connect these parts. So this is complete stationary wave. So this is how you can draw. Okay, so this one is the stationary wave. Now in this case, you need to understand this distance is given to us between this node and between this node, this node, this one here. So this distance between any two consecutive nodes we have discussed, this is equal to lambda by 2, and this one is also lambda by 2. So we can say this is lambda by 2, and this is also lambda by 2. Lambda by 2. So in this case, we have a wonderful answer is P. Yes. So we have 3 lambda by 2. This one is equal to 0.30 meters. I just converted into meters. Now from here we can find out value of lambda. So this will be 0.60 meters, and divided by this, so you will get this answer is 0.20 meters. Now lambda, you have speed of the sound is given, frequency you need to calculate. So frequency simply is equal to V over lambda. So we have speed of the sound, value of lambda is given to you, and this is 0.20. So we can simplify this. So we will have 20 here and multiply by 100. So this 0 we can cancel with this, and we can multiply, and we can get our final answer. That one, in this case, this one will be 50, and if you multiply, you will get 1650 hertz. So this is how you need to approach this problem. So this is our final answer. I hope this one is clear to you. So this is how you need to approach these problems, because this distance is given to us. So we can compare this one with the lambda, and we can find value of lambda. I hope this one is clear to you. The answer for this one is B. Let's go to next now. This is beautiful question, so please, little bit challenging maybe, but try to answer first of all by yourself. Spend some time on this one and try to answer. Okay, please try by yourself. Very nice question, conceptual question. Read carefully and try to answer. Let me give you some hints. You can keep on working. It has 2 antinodes and it has 2 nodes. So I hope you will simply say this is third harmonic. So this one, I hope you will simply say this one is third harmonic. So this one is third harmonic. If even you don't know this is third harmonic, we can also figure out frequency. Then I will teach you how to figure out that one. Question is asking you to calculate speed of the sound in the gas. Let me explain you this one. For this question, please, you need to understand. Question is asking you to calculate speed. So in this case, first thing you need to understand, what is the wavelength of this one? Wavelength. So you see, this is lambda by 4. We have 3/4 of the wave. 3/4 of the wave means third harmonic. So this is third harmonic. That's the reason I said this is third harmonic. So we have 3/4 of the wave inside this pipe. So simply in this case, I can say L is equal to 3 lambda by 4. From here we can find lambda, that will be equal to 4L by 3. This is, and you need to find out speed. So V will be equal to F times lambda. So we can say V is equal to F times 4L by 3. And in this case, speed is constant, because speed of the wave, it depends on type of the wave and medium. So you need to understand, speed of the wave, it depends on 2 main properties. One, it depends on type of wave. Different waves, the speed is different in the same medium, and it also depends on medium. If you change medium, speed of wave will change. In this case, medium is the same and type of wave is the same. It means speed is constant. So I will say speed is constant. So simply I can write down 3V over 4. This one has to be equal to F times L. Now in this case, you can see this is constant. This one is constant. So it means that you can take any value of the frequency and any value of L, that also will be constant. So you can take any point from this graph and you can calculate value of V. So I will write down V is equal to 4 FL divided by 3. Means just simply I'm copying this one. Now you can take any value of F, any value of L, but I will be taking this value. I'll take this value. So we have 10. You can also read from here value of frequency, that will be 2200. Now simply you can plug in these values. We have frequency that is 2200, and value of L, this is in centimeters. It means this is 0.10. and divided by this one. So your answer will be 300 meters per second. So this is how you need to approach this problem. I hope this one is clear to you. You can take any point, you can try by yourself later. I just have taken this point. So the answer for this one is C. This was the main point because this remain constant. So I can take any value of any point from here, means I can find frequency of that point at that point and L at that point, and I can figure out the speed. I hope this one is clear. Let's go to next one. Look at this question, try to answer. Not difficult question, pretty straightforward one. I hope you can find the answer quickly, but little bit tricky question, not difficult. It's tricky. You need to understand the point, what question is asking you. Contain a standing wave. Let me give you another point here. We can say with same wavelength. So let me little bit clarify this question to you. With the same wavelength. Stationary wave with the same wavelength. So please try to figure out which one. The best way to answer this problem is find the lambda for this one. Lambda for this one, I hope you will say that is equal to 4 times L. 4L. Because this is antinode here. So you have antinode here at the open end and you will have node at the closed end. So you can draw the stationary wave inside this pipe. So this is the stationary wave inside this pipe. So lambda is equal to 4L. Now you can calculate lambda for each of them. Where you have lambda is equal to 4L, that is the right answer. So in this case, this is speaker. So here we will have antinode and here also will be antinode. So somewhere here we will have node. In this case, we will have antinode because this side is open, speaker is here. So this side will be node. And here you will have antinode and here will be antinode, open ends, and here will be node. In this case, we will have antinode here and we will have antinode here. So you can also draw the stationary wave inside this one. So let me draw stationary wave inside these pipes. So here not very just approximate, so you can at least get some idea how to draw inside. So point is here. So if you want to draw in a little bit precise way, we can draw like this, a bit better. Okay, this one. And for this one, you can see, so we will have antinode here. So this is how you can draw inside. And here you will have this one. Okay, here. And for this one, antinode, so here we will have node here. So you can also draw for this one like this. Okay, now please try to find out which has the same wavelength that is equal to 4L. If you look at this one, in this case, we will have 2L. That one will be equal to 2 lambda by 4. So you can cancel 2 with 2 and you will have lambda that is equal to 4L. 4L. So this one, first one. How about for the second one? You will have 2L. This is equal to lambda by 4. So from here we can say lambda that is equal to 8 times L. How about here? So we will have L that is equal to 2 lambda by 4. So we can cancel this one. So we will get this is lambda by 2. So in simply you will say lambda will be equal to 2 times L. How about for this one? So you have 2 quarters. So L is equal to 2 quarters. So this is 2 lambda by 4. So it means this is lambda by 2. So the lambda is equal to 2L. So which one is the right answer? I hope you will say this one is the right answer. Okay, because these two, they have the same wavelength. So the answer for this question is A. So this is how you need to figure out answer.